Part 2 of significance testing. This video will look at two-sided tests and their relationship to confidence intervals. So, we have the Center for Disease Control and Prevention, the CDC, claiming that 50% of high school students have never smoked a cigarette. A student is wondering whether this national result is true at his large urban high school. So for his class, he's going to do an SRS of 150 students from his school, and he gets responses, and 90 say they have never smoked a cigarette. What should this student conclude? Give appropriate evidence to support your answer. So we're going to do a significance test at alpha equals 0.05 significance level, with the null hypothesis being that the proportion is 0.5 and the alternative hypothesis being that it is not 0.5. And P is the actual proportion in Taeyeon's school who would say they have never smoked cigarettes. So we have to check our three conditions. If they are met, we're going to do a one sample z-test for the population proportion. We are random, we used an SRS. Normal. If the null hypothesis is true, we're using P sub 0 to be 0.5, n times P0 is 75, n times 1 minus P0 is 75. These are both at least 10. Normal distribution is a safe approximation. And our independent condition is met also, but because we are sampling without replacement, these trials are not independent, but we meet our 10% condition. It's safe to assume that if it is a large urban high school, we probably have at least 1,500 students in the school. So now we do. Our p hat is 0.6. Our test statistic, 2.45. Our p-value, we're going to use our table A, or we're going to use our calculator, and we find that the area in each tail of this two-tailed test is 0.0071. So our total p-value will be double that because both tails have the same area. We add them together or simply double what we got. Our p-value is 0.0142. So since this p-value is less than our chosen significance level, we have sufficient evidence to reject the null hypothesis and conclude that the proportion of students at Taeyeon School who say they have never smoked differs from the national result of 0.5. Now let's turn our attention to confidence intervals again. The result of a significance test, we either reject the null hypothesis or fail to reject the null hypothesis. And when we reject the null hypothesis, we're kind of curious what the actual proportion is. We know it's greater than that or less than that or not equal to that, but what is it? We can answer that question by creating a confidence interval for the problem. So let's deal with Taeyeon again. He found 90 out of 150 students in an SRS say they have never smoked. Before we can construct a confidence interval, we have to check NP and N1 minus P. We get 90 and 60. And remember, what we're using is a P hat here, not a P. And when we calculate our confidence interval, it's P hat plus or minus our critical value times the standard deviation, but we're using our standard error this time, so P hat instead of P or P naught. And we get our confidence interval from 5.22 to 6.78, meaning we're 95% confident that that interval captures the true proportion of students at his high school who would say they have never smoked a cigarette. So we are seeing that it's higher than what the national average is. Our 95% confidence interval gives us an approximate range of p-zeros that would not be rejected by a two-sided test at the 0.05 significance level. Notice 0.05 significance level 95% confidence interval, those add up to 100%. But our link isn't perfect because with the confidence interval, we're using the standard error. We're using p hat to calculate that standard error. And with our test statistic, with our finding that, we are using p0 from the null hypothesis. So we're using slightly different values in our calculations, but they're very closely related. So here's a picture of a two-sided test. A two-sided test at a significance level of, for instance, 0.05 and a 95% confidence interval, notice adding up to 100%, gives similar information about the population's parameter. If the sample proportion falls in the fail to reject region, this part in here, the resulting 95% confidence interval would include the null value. In that case, both the significance test and the confidence interval would be unable to rule out that null proportion as a plausible parameter value. But if the sample proportion were to fall in the reject null hypothesis region, out in one of these tails, the resulting 95% confidence interval would not include the null proportion, and in that case, both the significance test and the confidence interval would provide evidence that the null proportion is not the parameter value. And the confidence interval would give us a pretty good idea of what that true parameter value should be at that particular confidence level. So here is a summary. Make sure you look at this, make sure you understand what these summarized statements are saying. In the next section, we will look at what we do for means.